everybody, Ms. Lee here. Today we're talking about concavity. So concavity in terms of derivatives is where your second derivative sign changes. So when you are looking for something that's concave up, you're looking for a graph that looks like it's like an open bowl or something where it caves upward. So that's concave up. And then just for reference, concave down looks something more like this. Okay, so these are our examples of concave up versus concave down. Okay, so concave up is going to be where f double prime of x is positive or greater than 0, or where f prime of x is increasing. Okay, so if you think about that, that makes sense, because if f double prime is the derivative of f prime and f double prime is positive, that would mean that f prime would need to be increasing. Okay, so again, that makes sense because something's derivative is positive when it is increasing. So f prime is increasing or f double prime is greater than 0 means f of x is concave up. Okay, so concave up for f of x. We'll say f of x right here. Okay, and then concave down for f of x, I'm sure you can figure this out, is where f double prime of x is less than 0 or negative, or where f prime of x is decreasing. Okay, with that being said, we'll go ahead and do an example. So I will show you how to find where a function is concave up or concave down. So our example, we're going to do a cubic function. So we are going to find the intervals of concavity for f of x equals x cubed minus 3x squared plus 6x minus 23. So we are finding the intervals of concavity for f of x equals x cubed minus 3x squared plus 6x minus 23. So as we stated up here, concavity is determined by the second derivative. So the first step would be to take the second derivative. So find f double prime of x. Okay, so first we got to find f prime of x. So f prime of x equals, and the derivative of x cubed is 3x squared minus the derivative of 3x squared is 6x, and then plus the derivative of 6x, the derivative of 6x is 6, and the derivative of 23 is 0. And so this is f prime of x. We'll take the derivative again, and we get f double prime of x equals 6x minus 6. Okay, so same thing as when you're doing increasing and decreasing intervals, it's going to be the same for concavity. So the only difference is we're using the second derivative versus the first derivative. So we'll set the second derivative equal to 0. And you get 6x minus 6 equals 0. So if you solve that, you get 6x equals 6, and so x equals 1. Okay. Again, this is the same as finding the intervals of increasing and decreasing, just we're using the second derivative. So again, we're going to put it on the number line, and we're going to check each interval. So this number line just has x equals 1 then. So x equals 1. and then we're going to plug the numbers into the second derivative. So we're going to check it with the second derivative. So over here, we're going to plug in, say, like 0. And again, we're plugging it into the second derivative. So f double prime of 0 equals, and so we plug it into 6x minus 6. That's going to be negative 6. So that's negative. So this is a sign chart here. We're going to put negative here. And so negative, f double prime is negative, means concave down. And then we'll plug in a number over here. So let's plug in, say, like 2. Okay, so if you plug in 2 into the second derivative, f double prime of 2 equals 6 times 2 minus 6. That's going to be 12 minus 6. 12 minus 6 is just 6. That's positive. And when f double prime of x is positive, that's going to be concave up. That interval is going to be concave up for f of x. Okay. So from this number line, what we found is that f of x is concave up on the interval from 1 to infinity. And that's because f double prime of x is greater than 0 there. And then f of x is concave down from negative infinity to 1. And that's because f double prime of x is less than 0 on that interval. Okay, so there we have it. We found the intervals of concavity. I'm just going to add one little thing here. So x equals 1 is a very special point because that's where f of x changes concavity. And what we call this very special point is a point of inflection. Okay, so x equals 1, and we're going to find the actual point. So we'll plug 1 into the original function. So that'll be f of 1 equals 1 cubed minus 3 times 1 squared plus 6 times 1 minus 23, which is just 1 minus 3 plus 6 minus 23. I believe that's negative 19. 1 comma negative 19 is the point of inflection. Because that is where f of x changes concavity. Okay, so let's actually write that down. So a point of inflection is where f of x changes concavity. Okay. So now you know how to find intervals of concavity and you know what a point of inflection is. Woohoo! Happy day!